Hello friends. I decided to share with you another one of my developments for Home Assistant. I hope it will be useful and save you a lot of time. But first, I want to explain what it is about. So, in my smart home system, like many others, there are sensors that show the total energy consumption for the entire apartment, in my case for each of the 3 phases. Right now, this role is performed by the built-in sensors of the die inverter. You can find a video about its integration via the link in the description. Earlier, these were zigbee current energy monitors. Their reviews are there as well. This is not fundamentally important. The key point is that these are data about the total consumption of the whole house. The logical next step, as I see it, is to break this consumption down by specific devices and present it conveniently in the interface. That is exactly what this video tutorial will be about. And before we begin, as usual, I ask you to like this video so more people interested in smart home topics can find it, and subscribe to my channel if you haven't done so already. Let's go step by step through this task. This is what, in my case, one of the pages of my interface looks like, which I use to display electricity-related data. Within this case, the first column is not of interest to us, but all the others are what we will be working with. The main part here is occupied by information about total energy consumption and grid voltage. In my case, I have a 3-phase input. For single phase, this is still relevant, just the logic will be slightly simpler. At the very top, numerical values of current power consumption and voltage. Slightly below, graphs that allow you to analyze the history of changes. Everything here is quite simple. The data comes from physical sensors installed at the input to the house. Whether it is a relay with energy monitoring, monitors with a current transformer, or an inverter, it does not matter. In the lower part of the window, detailed breakdown, the devices that create this load. And this is the most labor-intensive part of the work. In addition to the actual list of consuming devices, here you can also see 2 values for each phase, known and unknown load. Known is the sum of those devices that have already been identified. Accordingly, unknown is the remainder of what has not yet been identified. To create convenient and, most importantly, dynamically changing lists in the interface, I use AutoEntities cards. I made a tutorial about them 5 years ago. The link is in the description. Their essence is that they support filters, thanks to which they display or, on the contrary, exclude all entities matching a template. In this case, all sensors whose names contain phase_L1, except for resulting sensors, with known or unknown load. And not just as a list, but only if consumption is above 1 watt. For the second and third phases, the same applies. This is much more convenient than manually specifying each entity. But for this, all entities must have unified names. And for this purpose, I have a separate package for such entities. Although I usually share my packages with you, in this case it does not make sense, since with the help of the constructor, which I will share, you will generate similar packages yourself. And if you still don't know what it is, you will also find a link to the tutorial in the description. The package consists of several blocks. Let's start with customization. It is not directly related to logic. Its task is to display clear names in the interface. And so as not to manually define them for each entity, my constructor automatically adds them here. After reloading the configuration, all entities will be displayed with convenient and readable names. The next block is recorder, what is written to the database. I hope all viewers have moved away from the bad practice of writing everything indiscriminately, excessively inflating database size with things you never use. The only correct approach is to write only what you need, and the package structure allows this. Therefore, the constructor writes each added sensor into this block as well, since energy monitoring history falls into the category of useful data. And the largest block, template sensors. I call this concept virtualization, as it allows you to move away from dependence on physical sensors and create your own structure, partly linked to hardware sensors and partly completely independent. The simplest option is using a hardware energy monitoring sensor. The template sensor simply takes its value, converted into a floating point number. If there is no data, it equals 0. The advantage here is that if you replace, for example, a smart plug, you only need to specify it in one place. Here, the template will start taking data from it. While both the history is preserved and there is no need to make changes in customization, recorder, or other templates or automations where it is used. I also have two calculated sensors. This one is designed for a fixed load, 40 watts. It monitors the state of a light fixture that always operates in one mode and consumes 40 watts when on. I will show how to determine this a bit later. Therefore, when the light is on, the sensor value is 40. When off, it is 0. The second option is a bit more complex. It is designed for lights that operate with variable brightness. Here you need to determine two values, power at minimum and maximum brightness. Based on these, the intermediate power will be calculated depending on brightness. These sensors are also generated automatically. For those interested, this is what its code and resulting output look like. Here the power at minimum brightness is set to 10 watts, at maximum, 50 watts. If the chandelier is off, the power equals 0. Currently, the brightness is set to 70%. The calculated power is 34 watts, which, by the way, matches what I observe on the total power sensor. In addition, for each phase, there are resulting sensors. This one shows the total power of all identified loads, simply summing them up. And here is another good piece of news. You don't need to do this manually. My constructor does it as well. And the difference between the readings of the external load sensor and the sum of identified loads shows the amount of power that still needs to be identified. As you can see, the logic is not very complicated, but manually defining every sensor in all places is long and tedious, so I could never bring myself to do it. But then another idea came to my mind. As a griffin in one cartoon, who was teaching an ostrich to fly, said, "Better to lose a day, but then fly it in an hour." After all, this package is structurally quite simple, just bulky. So I decided to create a constructor that would handle the boring tasks itself, such as writing template sensors and adding them to customization, recorder blocks, and formulas of resulting sensors. To simplify the task as much as possible, it is made as a regular web page, an HTML file, which is created with any text editor. You paste the code into it, which you will find via the link in the description, and save it with any name and the .html extension. After that, you open it in a browser. I use Google Chrome, and you will see this constructor interface. Now let's go through its capabilities. I have developed a habit. If I make an interesting case, I initially approach it from the perspective of how it can be demonstrated in a review and replicated. That is why for the constructor, I immediately made two modes, for one phase and for three. Although personally, I only need the three-phase version. The field on the left is the package name, what will appear in its header without indentation. All other sections will be nested inside it. The date is set automatically. I also added the ability to import a project with all settings and created sensors. By default, everything is stored in the browser's local storage, but it may be deleted when cleared, so storing everything in an external file is useful. To create a new project, click Create. If you already have a saved project, click Import and select that file. For demonstration, I created a project for one phase. A bit later, I will show three. The page displays a field for entering the name of the input sensor. This is the sensor that measures total consumption. Slightly below, a field appears for adding a load sensor. For a single-phase project, there is only one. We add the name of the total power sensor. This can be either the name of a physical sensor or a template one, depending on your setup. The logic will treat its value as the total power consumed by the house. Now you can add the first load power sensor. Internal ID. This is the technical name of the template sensor. You can set any name. The phase prefix will be added automatically. Next, name. This is what will appear in the customization section, the friendly name for the interface. If this is a power sensor, skip the calculated field, and the last field is the technical name of this power sensor. Copy it from the device page in Home Assistant. Click Add. Below on the page is the list of added sensors, and here our first sensor is displayed. If necessary, it can be deleted, and it will also be automatically removed from all package blocks. Below that is a block of buttons. Generate YAML. In this version, it is already generated automatically after adding or removing sensors, but I kept it just in case. Copy. Copies the entire created package to the clipboard. This is more convenient than selecting and copying manually. Export and import project file. This is saving and restoring all settings to or from a file. By default, settings are stored in the browser's local storage. If you close the page and open it tomorrow, all your data will still be there, but clearing the browser may delete it, so there is an option to save it to a file. Download YAML as a file if needed. I personally find copying more convenient, but I added this option as well. And resetting all settings returns the constructor to its initial state. Below is a text window that shows the generated package, the template of which we have already discussed. The main difference between versions for 1 and 3 phases is the prefixes in template sensor names and the number of calculated sensors, known and unknown load. Let's take a closer look. Click the copy button. The entire package text is now in the clipboard. This option is the most convenient for me, but you can also use the download YAML button. What do we have here? Customization and recorder blocks, which contain the sensor we added and 2 calculated ones created automatically by the constructor. And the template block, at the beginning there is the added sensor, which is simply equal to the value of the hardware power sensor. The calculated sensor of known load currently contains only one, the one we added, and unknown load, where the known load is subtracted from the total input power. Now let's look at the other options I added. A calculated object. This is a load without energy monitoring, but with a known power when operating. To add one, check this checkbox. After that, another checkbox appears below. Don't touch it yet. I will explain it a bit later. And an additional field, power. The addition process is similar. First, the internal ID, technical name of the template sensor, user-friendly name. Then the name of the object the template will monitor. In my example, this is a light fixture. Similarly, you can use a relay that controls the load, or, for example, a binary template sensor that will turn on based on a template that determines when this load is active. And in the last field, enter the fixed power value. Add it. Now we have a second sensor, type, calculated, unlike the first, measured. If the specified object is turned on, in my case, the light fixture, this sensor takes the specified value. In this example, 20 watts. Now let's examine the third type of object that I added in this version of the constructor. I'll say right away that I plan to add new variants as well. I already have some ideas. I will report updates in my Telegram channels. Links are in the description. The third type is intended for lights with adjustable brightness. For this, you need to check both checkboxes in sequence, and 2 fields will appear below for entering minimum and maximum power. The addition process is similar to the previous one, except that there are 2 power values at minimum and maximum brightness. The current power will be calculated based on the brightness attribute value. Add it. These are all 3 types of sensors available in this version of my constructor, 1 measured and 2 calculated, for fixed load and for a light with adjustable brightness. I will gladly read your thoughts and ideas about this in the comments. Let's take a look at the package, what it looks like now. The sensors we added have appeared in the customization and recorder blocks, exactly as intended. But to apply these settings, I mean the recorder, a Home Assistant restart is required. Here is the template section and all sensor types available in this version of the constructor. Fixed power that is set when the specified object is turned on, calculated power based on the brightness attribute for lights, and actual measured power from an energy monitoring sensor. The calculated sensor of known load already has 3 components, while the unknown load has the same structure regardless of the number of added sensors. Saving all data and settings to an external file is done using the Export JSON button. Let me remind you once again, by default all data is stored in the browser's local storage and loaded automatically, but if you clear the browser, it will be deleted as well, so do not neglect exporting everything to an external file. After pressing the Export button, the file is downloaded to the folder specified in your browser settings for downloads. Another option is resetting all data to, so to speak, factory settings. If you want to start from scratch, click and confirm in the pop-up window. And we are back to the same state as at the beginning. But besides creating, there is also an option to import a saved project. As an example for a 3-phase system, I will open my real project used in my smart home system. This is what the constructor looks like for 3 phases. The concept is exactly the same, except that there are 3 total power sensors for each phase, and load sensors are added to different phases depending on how they are connected. The same logic, but multiplied by 3. This is part of the list of sensors I added. As you can see, all types are present, but I think new ones will appear as well, since there is no limit to perfection. I cannot come up with all possible options myself, so I also rely on your suggestions and advice in the comments. Now a bit about the process of determining which load belongs to which phase. For energy monitoring sensors, I created an additional auto entities card, in the filter of which I added all power sensors with a load above 1 watt, and in exclusions, everything I have already identified. This is what it looks like for me. I placed it under the second phase column. It is more convenient for me, and the card is temporary. Right now it only displays one of the sensors that has not yet been assigned to a phase. To assign one of the smart plugs with energy monitoring, I briefly plug in something powerful to it to immediately see which phase shows an increase in unknown load. In this case, the third one. Then it only remains to add the sensor to the corresponding column. With small loads without energy monitoring, there is more hassle. You need to stabilize consumption as much as possible so there are no spikes. Then, by observing the unknown load values, try turning it on and off. In this case, it is a lighting block of 3 small fixtures. Before turning it on, the unknown load on phase 1 is 82.55 watts. After turning it on, 96.55 watts. We can repeat to be sure. In this case, you can add a fixed load when this group is turned on, 14 watts. The brightness does not change here. With brightness, it is a bit more complicated. First, you need to find the phase. I usually do this at maximum brightness. Then calculate the power values at minimum and maximum. Also, do not expect very low power at low brightness. For example, my chandeliers at 1% brightness consume about 10 watts. When turned off, almost 0. In general, this is all I can tell so far about the task of identifying load power and the constructor for automating the package. The answer to the question, why do this at all? I leave to your discretion. If you have such a question, then most likely you simply do not need it. My package is still being refined. I have already added everything that was easiest, and what remains requires further analysis and thinking about how to integrate it here as well. I will also think about additional types of sensors. For example, when in the chain, a main sensor, load, there is another energy monitoring sensor. For example, a DN rail relay from which power is distributed to several loads with their own energy monitoring. As another layer of detail, I will report updates on my social networks. That's all for now. I hope the video was interesting and useful for you. I would appreciate your likes. They help promote the video on YouTube. If you don't want to miss new videos, subscribe to my channel. In the description under the video, I will leave links to all mentioned resources, as well as to my Telegram channels and social networks, and groups for discussing smart home topics. Feel free to join. It will be interesting. Thank you for your attention. See you next time. Peace to everyone.